Have you ever wondered how a gigantic, super long web address gets magically squeezed into a tiny, neat little link? Well, today we're going to pull back the curtain on a service you probably use every single day, the URL Shortener. We are going to build one from the ground up, and you'll be amazed at how many core internet design principles it teaches us. You know, it all starts with a problem we've all had. You've got this ridiculously long web address. It's just a mess of letters, numbers, symbols, and you need to share it. How do you possibly take all of that chaos and turn it into something short, sweet, and shareable? And you see, this simple question, it's a bit of a Trojan horse. Answering it properly is basically a masterclass in building huge, scalable internet services. It forces us to think about data, about insane speed, and about rock-solid reliability. All the things that make the modern web actually work. So that's what we're going to do. Let's just roll up our sleeves and actually architect a complete URL shortening service piece by piece right here, right now. Okay, first things first, what are we really building here? Honestly, the best way to think about it is like a coat check. Yeah, a coat check at a big event. You hand over your big, bulky coat, that's your long URL, and in return, you get this tiny little ticket. That ticket, that's your short link. Simple as that. So to put it a bit more formally, a URL shortener is a service that does exactly what it says on the tin. It takes that long URL, cooks up a much shorter, totally unique alias, and then whenever someone uses that little alias, it just zips them straight over to the original destination. If you boil it all down, the entire system really just does three main jobs. First, it's got to create that short link when you give it a long one. Second, and this is the big one, it needs to redirect people from that short link back to the long one. And finally, there's a third, super important operation. It has to track usage so we can get all that juicy data on how many times our links are getting clicked. All right, let's tackle that first operation, actually creating the link. Now, this might sound easy, but getting this right is the absolute heart of the whole system. And it's a real balancing act between two critical and kind of competing ideas. Right, so the fundamental question we have to answer is this. How do we generate this little string of characters, our short link, so that it's guaranteed to be one of a kind across literally billions of links, but also stays nice and tiny? And let me be clear, these two things are non-negotiable. Uniqueness is an absolute must. I mean, can you imagine if two different websites shared this same short link? It'd be a total disaster. And shortness, well, that's the whole point, right? We've got to stay in that sweet spot, maybe 5 to 8 characters, just like the services we use every day. And the solution? Oh, it's so elegant. It's a two-step process. First, for every new URL that comes in, we generate a globally unique ID. Think of it like a ticket number that just goes up and up and up and never repeats. Then, we take that giant number and we encode it. Specifically, we turn it into a base 62 string. Now, why base 62? Simple. It uses all the numbers, all the lowercase letters, and all the uppercase letters, every character that's totally safe to use in a URL. And this little trick gives us a mind-boggling number of combinations in a tiny space. With just 7 characters, you can create over 3.5 trillion unique links. That should last us a while. So we've got a really clever way to make unique short links. Awesome. But that's only half the battle. The other side of the coin, the thing that happens way more often, is the redirect. And when somebody clicks that link, it can't just be fast, it has to feel completely instantaneous. Just imagine, one of our links gets shared by a huge celebrity. All of a sudden, we're not getting a few clicks, we're getting millions of clicks a minute. If every single one of those clicks has to go all the way back to our main database to look up the long URL, our whole system is just going to grind to a halt. It'll be toast. And this right here shows us the fundamental truth of our service. It is overwhelmingly read-heavy. For every single time we create a link, that's a write, we could see hundreds, maybe even thousands of clicks, which are all reads. What that means is our entire design has to be obsessed with read speed. So, we need a faster way to deal with the popular links. Let's go back to our coat check analogy. If some guests are running in and out all night, you don't keep putting their coats way in the back room, right? No, you keep it right there by the front door for super quick access. That is exactly what a cache is for our data. Okay, so the technical fix here is something called a read-through cache, often built with a tool like Redis. It's basically a super fast, in-memory data store that acts like a helpful assistant sitting in front of our main database. When a request comes in, we ask the cache first. If the link's there, bam, we serve it instantly. If not, okay, we go get it from the main database.
But, and this is the clever part, we also stick a copy in the cache for the next person who asks. This just makes everything dramatically faster.
Okay, our cache is making redirects lightning fast. We're feeling good. But there's another much bigger problem looming on the horizon. What happens when we have billions of links and our one single database just plain runs out of room? This is where we have to start designing for absolutely massive scale.
Let's switch up our analogy. Think of our database as one single gigantic library that's supposed to hold every book ever written. I don't care how big you build it, eventually you are going to run out of shelf space. It's inevitable. So, the solution isn't to build one infinitely huge library. No, the smart solution is to build lots of smaller, more manageable libraries. We could have one library just for books that start with the letter A, another for B, and so on.
In the world of system design, this idea is called sharding. It's just a fancy word for breaking up a massive database into smaller chunks, or shards, and spreading them out across a bunch of different servers. This lets us scale out horizontally, which just means when we need more space, we just add more computers. It's beautiful. And here, my friends, is where our earlier design choices really start to pay off. It's a ta-da moment! Remember that cool base 62 encoded ID we made? Well, the very first character of that ID can be our shard key. If a short link starts with A, we know instantly to look in database A. If it starts with a capital Z, we look in database Z. This makes finding our data incredibly fast and efficient, even when we have billions and billions of entries. So, our system is now fast and it's scalable. We're almost there. But what about that third operation we talked about way back at the beginning? Let's figure out how to add analytics without slowing down the super fast system we've worked so hard to build. The trick here is to not mix these two jobs together. The user's redirect has to be instantaneous. Writing data to a database to count a click takes time, even if it's milliseconds. So when a click comes in, our system does two things at the exact same time. It immediately redirects the user to their destination, and in parallel, it fires off a quick message to a completely separate analytics service to log the click. The user never ever has to wait for the analytics part. They're already on their way. And after all of that design work, you know what? The entire system, all that complexity, is controlled through just two simple doorways, two API endpoints. You use a post request to make a new short link, and you use a get request to use one. That's it. All that power hidden behind this beautiful, simple interface. And there you have it, a scalable, high-performance URL shortener designed from the ground up. But you know, the work of a system designer is never truly done. What would you do next? How would you let users create their own custom vanity URLs, like tinyurl.com/mycoollink? And even more importantly, how would you build a system to detect and block malicious links from scammers? As you can see, the design challenges just keep getting bigger and more interesting.